right, so we're still talking about the surface area or the area ratios, and just to kind of quickly recap, we said that the areas are going to be enlarged by a scale factor or a zoom factor of n squared. So whatever the sides might be, then the area is just going to be enlarged by n squared. Okay, so here in our first example, the two triangles are similar. That's always important that we know we have similarity ratios. Find the area of the larger triangle. So when we look at some of these dimensions, we can see the base of the first triangle is 7 and the base of the larger triangle is 21. So that's quite a big difference, 7 to 21. How many times bigger is the shape? Well, 7 goes into 21 3 times. So then what we're going to do is we're going to work out our area ratio. So remember we said the ratio is always squared, so we're just going to take our sides, 3, and we're going to square them. So our area ratio is 9. So the areas are 9 times larger in the second figure than they are in the first figure. So if our smaller figure has an area of 20 centimeters squared, then we are just going to multiply by the ratio, which is 9 times bigger for the area, and that's going to give us our area of the new shape, 180 centimeters squared. Okay, and that's all that is. So it's a much larger triangle, and that's because we can see the dimensions of that triangle are much larger as well. So then what about some rectangles? So here rectangles are a little easier to work with, but they're still, we know the area of this rectangle, and we know we have one length. We could work out, undo, figure out the base, and then work through our formulas. But if we're just trying to find the area of the smaller shape, we need to know how many times larger is the bigger shape, and our bigger shape is, we can see here, 5 times larger, which means our area ratio would be 5 squared, or 25 times larger. So the areas are 25 times larger. From here to here, it's 25 times larger to get the area. So what we want to do is figure out, well, what's the smaller one? So instead of multiplying by 25, we want to get the smaller shape. So we are simply going to take our area that we were given and we will divide. We're going to undo that multiplication. So 400 divided by 25 gives us an area of 16. So the smaller shape has an area of 16 centimeters squared. And so then we're just kind of using those ratios to work everything out. So now when we look, this also holds true for surface areas, and that's because the surface area of a shape is just the total of all of the areas. That's all surface area is. So we see here we've got our two prisms. They are similar. The area of the smaller prism is 72 square units. We want to know what is the surface area of the larger. So we want to know the surface area of this one. Okay. So again, we're going to look at what is the scale factor. What's our dimensions? How many times larger is the shape? So we have a side of 6 and a corresponding side of 12. So we can see that it is 2 times larger, which means our ratio is going to be, it's 2 squared because it's area, or 4 times larger for the area. So the same thing holds true, that if the surface area of the smaller shape is 72 units squared, then our ratio would be 4 times larger for the area. So we'll just do 72 times 4, which gives us a ratio, or a new surface area, of 288 square units. And that's all we're looking for. What's the surface area? So we don't have to figure out the missing dimensions and work it all out because we know they're similar solids. We can simply use that ratio to get us our answer without having to do a whole lot of extra work. So then one more here, looking at these prisms, again, they're similar. The surface area of the larger prism this time is 252 units squared, or square centimeters, I should say. And we want to know what's the area of the smaller. What's the surface area of this smaller figure? So here again, how many times bigger are the shapes? So our shapes, we are going from 4 to 12. So we can see that's 3 times larger. So what we want to know is, okay, well, what would our area ratio be? So again, area ratio is always squared. So we know that the area ratio would be 9 times larger. So if we want to find the smaller figure, then again, we're just undoing the math. So if we know the bigger one is 252, then to get the smaller one, to undo that multiplication, we'll divide by 9. And so 252 divided by 9 will give us our surface area of the smaller figure to be 28 centimeters squared.